Now we have to look at three ways of transferring energy: conduction, convection, and radiation. Conduction is caused by intermolecular and electron collision. Convection is caused by the transfer of fluids, like gases or liquids, via the fact that you might have different densities as they are heated. Radiation is transferred by electromagnetic waves. Now conduction. Now when you get some contact between two surfaces, then you can have conduction. So what happens is the particles vibrate and these particles collide with their adjacent particles or adjacent molecules. So this kinetic energy is passed from one particle to the adjacent particle. If you have free electrons, for example in a metal, these free electrons can move between the atoms much more quickly, and they can transfer this thermal energy, they can conduct this energy much quicker. In conduction, the material itself is not transferred, only the heat is transferred. And here we have a graphic which demonstrates it. Here we have the conduction of heat. Notice the particles close to the flame are vibrating a great deal, and they pass on the vibrations to the adjacent particles, which pass on to the adjacent to those, and so on. And this way the thermal energy is transferred along this solid. This solid could be, for example, a metal bar or something like that. It takes some time for the thermal energy to be transferred. The next is convection. This occurs in a fluid, like a gas or liquid. You have an area of high temperature, the particles vibrate, they collide more, and they basically push each other further apart. In doing this, they will occupy more volume and become less dense. Less dense materials are basically become more buoyant and are pushed up. As this material is pushed up, this material is transferred and the thermal energy is transferred with it. This is a beaker full of liquid, is heated here. So what happens, this volume would start to expand as it heats up, and then it rises. The volume is less dense than the liquid around it, so it will rise and then move to the top. This warm fluid will then circulate, and it basically forms a convection current. The cooler liquid comes down, and this cooler fluid will replace the fluid that has been heated. So you will get this circle of convection. It's called a convection current. And this is what it looks like. Notice that at the bottom this amount of fluid is expanding, becomes light, and will move to the top. In the meantime, the heat is transferred to the top. So this is why we say heat rises. In convection, it does rise because the medium that carries it becomes less dense than the medium around it, and it will rise upwards. Radiation. Energy is radiated and is transferred as radiation waves or electromagnetic waves. The amount of radiation, or rather the intensity, and the wavelength lambda max, which is the wavelength of maximum intensity, depends on the temperature. Black body is a perfect emitter. Here again, the material is not transferred, the energy is transferred via electromagnetic waves. And this is a black body diagram. We'll look at it in a bit more detail. Notice that the cooler the substance, 3000 Kelvin, the intensity is very low. As it heats up, the area of this curve, which basically gives you the total intensity over all wavelengths, increases very rapidly. Also, the color of it, or wavelength of maximum intensity, decreases. We will look at this again. This graph is one of the most important graphs that we will use. It is also used in astrophysics. So this we'll come back to. Bye bye.